What's up everyone, this is Ryan here, and in this video we are going to be talking about our presenter and contract interface and all that good stuff. But before we get into that, I wanted to sort of overview one more time our basic structure for the software architecture. So as you can see, for view classes we have calculator activity, input fragment, and display fragment. And what I've done is I've basically lumped those all together into a single view. Now, in some scenarios, that's not actually going to be correct because, generally speaking, from what I've read, model view presenter is supposed to have a 1-to-1-to-1 ratio of views to presenters to models. Now, the reason why I've done things in sort of this way in particular is for a number of reasons, but mainly I didn't want to create a scenario where I had to create another presenter and another model and sort of overcomplicate things. One way I could have actually solved that problem is just sticking to one fragment for the entire user interface, but I also wanted to show how you can build a user interface with multiple fragments, yada yada yada. So longer story short, I've kind of cut a corner here and just considered the activity sort of its own view and the input fragment being constituent parts of that view. So I just wanted to make mention of that in case anyone wants to give me shit. Yeah, that is sort of something that I could have tackled differently, and I'm fully willing to admit that. Anyways, as you can see, we have a bunch of arrows and some words drawn between our colored blocks here, and those basically represent interfaces. And I said in the previous video, you're going to need to know what an interface is ahead of time, for the most part. My quick, simple explanation for it is that it's basically just a channel of communication between things that don't need to know each other. So I'm struggling to think of an example, but in a place that I've worked in the past, I worked in a kitchen, and there was a kitchen that was on a floor below the actual dining room. And in order to sort of send stuff between there, we had an elevator, or a dumbwaiter as it's sort of properly called. And so what would happen is that we would receive the bills, and then the food would get made, and then we'd put the food in the elevator and then send it up to the next level. So in a sense, you can kind of think of that elevator, or dumbwaiter as it's called, as being the interface there. And basically, it's not the best example, but I'm doing my best here. I'll do an actual video on this. Anyways, let's just leave it at that. It's a communication channel, and it's how our different layers are going to talk to each other. So, what's going to happen is when the input fragment or the display fragment receives any kind of a user input event, any button click, it's going to pass that input to the calculator presenter, and then the calculator presenter is going to pass that input to the calculation class, which functions as our model. Now, as I mentioned before, our model is going to actually almost be kind of a presenter in its own right, because it is going to do some sort of checking. It's going to decide whether the input that it receives from calculator presenter is valid or not, and then it's going to return a result, either a valid result or an invalid result based on that. So again, like, the thing about these software architecture patterns is that if it makes a little bit of sense to deviate from them, then there's nothing really wrong with doing that, as long as it's an informed decision. The reason why this thing is kind of mucked up a bit is just as a result of the scope of the app being so tiny, we can kind of get away with making these kinds of exceptions. Anyways, moving on. What's going to happen is the calculation class, our model, is going to then pass that to calculator presenter, the result, either the result of the equation or like an error message. And then calculator presenter is going to pass that result, whatever it is, to display fragment. And so that sort of outlines the communications between our different classes. And I just wanted to give you a visual preview of that. Now, before I actually wrote these classes, before I actually wrote all this stuff in code, I did actually sit down with a piece of paper and draw this stuff out. Obviously, I didn't spend all this time making colored blocks and stuff like that. But what I'm trying to say is that this isn't something that I just sort of figured out all in my head. I actually sat down and drew this stuff out and worked it out that way. So anyways, let's see here. The only other thing I wanted to mention before we get into coding is why I'm going to be building this app kind of flawed. And it all sort of goes back to the same reason, but basically, um, we're not going to be handling application state. So when the user turns the phone, it's going to call on destroy in the activity, and then everything's going to get destroyed. Everything in our application is tied to the activity's lifecycle. Now, in most cases, especially if you're working with fragments, that's not going to be the case. You're going to want to preserve fragment state across the activity lifecycle and things of that nature. I've chosen not to handle that because this is a beginner Android tutorial, and I didn't want to just start adding more and more concepts because, quite frankly, I don't have time to do that. So what I'm trying to say here is that we're going to be not handling this situations because we're basically considering this app to be sort of a beta or alpha build. And I mentioned that in the very first video that was our goal here. So that's the first thing. Again, we're also not going to be worrying about long-running operations. And the reason for that is because, again, that would add a whole new sort of series of concepts that I would need to teach somehow to a beginner, and that's not something I really have the time or patience to do. I will cover those topics in more sort of advanced applications later that I build for you guys, but in this case, I just want to keep it really simple. Now, we're able to get away with this because we basically know ahead of time that we're not going to have long-running operations. Calculations are something that computers have been really good at doing for a long time. We're not communicating with a network. We're not communicating with a database. It's just we're calling a couple methods from a third-party library that's built in, and that's really going to be that. So in reality, it's going to be poor practice to not handle either of these things, to not handle application state properly, and to not handle asynchronous operations properly. But as I say, we're purposefully going to skip those for now. I might actually come back in the new year and build this application better, add some things to it, like maybe add some scientific uh, or just some more advanced operators and stuff like that to it. But for the time being, we're not going to handle those scenarios, and that's why. So hopefully that makes a little bit of sense. Feel free to give me shit if you want about this, but it's something I'll be revisiting, and I think that's all I should probably say about this. Let's get some coding done. Alright, so what we're going to do now is we're going to code our calculator contract class. So what I'll have you do is just open up your Java package, go to com.whatever you named your crap, .calculator, right click on it, go to new, and Java class. And we're going to call that Java class calculator contract. Make sure I spelled that right. And for kind, we're going to type or select interface. And everything's good there. Go ahead and hit OK. And you can just create this class from scratch if you're having difficulty. Just like literally make a new Java class and then retype it to that, reset it to that rather. And so what we're going to do is, so the purpose of this contract class is to sort of specify how our different components, so we're talking the input fragment, the display fragment, and the presenter, and we're going to create a sort of another interface later on for the model and presenter communication. But for now, this class is going to sort of specify how these different objects are going to talk to each other. So it's going to do two things. It's going to basically it's going to let each part know that something has happened, and if necessary, it's going to pass some data at the same time. So remember in just moments ago I said that it's kind of a communication channel. That's basically what's going on here. Now we're going to make actually three different sort of, I don't actually know what the technical name of these is, but I'm just going to call them sub-interfaces, and we'll see why. So within our main interface, we're just going to say interface publish to view, and we'll just create some brackets there. we're going to say interface forward display interaction to presenter. I know that's a stupidly long name. We'll get to why in a moment. And then we're also going to say forward input. There we go. Oh my god, come on. Input. Sorry about that. Forward input interaction to presenter. Now, why have I given these things stupidly long names? And yeah, this is up a little bit to debate. But when I create these interfaces, I personally like to have these names as explicit as possible because there's nothing more annoying to me than opening up someone's code and having a look through it, and you have to like fish around to figure out what the hell is going on here. So, for example, the names of these things, I've included the name of each part of our view, each fragment, right in the name of the interface. I've explicitly said that this is to forward something. It's so to pass something on. And I've said where it's going to. You don't actually have to follow this naming convention here, but I just... Oh, wow, I totally... Sorry, that's presenter. Presenter, wow. I just can't seem to spell. Anyways, as I was saying, I personally like to give these things really descriptive names. You can do whatever the hell you want. And moving on. So what's going to happen here? So forward display interaction to presenter. We're just going to type passes click events from our view display fragment to the presenter. And again, I'm adding some comments here just to make this even more explicit. That's really optional for you. I would suggest getting in the habit of doing stuff like this. We've actually really not been doing any comments, and there's a reason. I'm going to be revisiting that later on. But you do want to get in the habit of doing that. And then our last little comment here will be our view handles these methods. And that's actually supposed to say input fragment. And yeah, so that's all that's going on here. So we have three different things going on. If you remember at the start of the video, I showed you some little arrows and some colored blocks. So basically, publish to view is going to get called whenever our presenter wants to sort of publish the result of a calculation, and that's either going to be the result or it's going to be an error message to display fragment, which is the part of the view that we're talking about in this particular method. So we're going to, I'll just include a little note there, display fragment. And publish to view is going to have two different interface methods, void show result, and we're going to pass string result. And then it's also going to have a method void show toast message, and that's going to be string message. The names don't matter too much. And so what's going to happen is if the calculation is valid, if the expression which gets sent to our calculation object, which we'll code later, is valid, then it will return the result. If it's not valid, it's just going to return an error message like something invalid, and we'll deal with that later. And that's really all we need to do when it comes to handling what display fragment, how display fragment is going to respond to those particular events. For forward interaction to presenter, forward display interaction to presenter, we're going to say void on delete short click. So again, we're dealing with display fragment. And as I mentioned in the previous video, we had two little methods. So on delete long click. So we had a short click and a long click. And we don't need to pass anything. We just need to let the presenter know that this has happened. One of these things has happened. And since there's only one sort of... Well, I'll just leave it at that. I don't think I need to explain that further. And then we'll just finish this off here. So void on number click. And if it's not clear where I'm getting all this stuff from, it probably is, but we'll cover that in a moment. Void on decimal click. And let's see here. Let's just kind of speed this up a little bit. On evaluate click. And on operator click. And that's going to be string operator. Oops, operator. Okay, so what I've done is I've just gone through and created an interface method, which is going to correspond to each of these methods in our view. So for example, on click, on delete, short click, yada, yada, yada. And then what we'll do is we'll have this fragment implement its specific part of this interface and then handle it that way. So we're not actually going to do that in this video. We'll handle that in the next video. What we're going to do now is move on to coding our presenter, and then in the the next video, we'll cover the model, and then the last video will kind of be to tie everything together and sort of hook everything up. So without further ado, let's hop over to coding our presenter. Okay, so we're ready to start writing our calculator presenter. Now, when we do this, it's going to seem probably quite confusing at first because of the way we're going to be using these interfaces. So I'll do my best to explain it. If there's anything I can kind of clarify, please do let me know in the comments section, because if you're not sort of used to working with them, it can be very frustrating to try and figure out what's going on. So what we'll do is let's go ahead and right-click on the main package, go to New Java Class, and we're going to call that class Calculator Presenter. And go ahead and hit OK. Now, hopefully you know this by now, but the way that you implement an interface is that you use the implements keyword, and then you just type, for example, we need to implement calculator contract dot forward input blah blah blah, as well as calculator contract dot forward display blah blah blah. And I'll just clean that up a little bit there. Now, what does this mean? This basically means that this calculator presenter object is saying whatever gets sent through this communication channel or this communication channel, I will handle that. I will deal with this shit. So that's the important thing to realize here. So what we can do is you can see that it's showing up as red. I'm going to hit Alt-Enter in Android Studio, and then go to Implement Methods. And all this is doing is I just want to implement our contracts methods. I want to say, I'm going to handle this shit. So, now what we're going to do is, this is going to seem a little bit confusing. We're going to create a constructor, public calculator presenter. And this is where things are going to get confusing, so just stay with me. We're going to type calculator contract dot publish to view. Publish result. Oops, sorry, publish result. And what we're going to do is we're actually going to also create a variable. This, private calculator blah 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 contract dot publish to view. Publish result. Stop auto-completing that way, you piece of shit. Okay, there we go. Publish result. And then we say this dot publish result equals publish result. And I'll explain what the hell is going on here now. So, using your Java knowledge, you can see that we have a constructor here. And whenever our presenter is created, whenever we call this method here, it's going to require a interface, which seems a bit strange, called publish result. So what is that? And this is sort of the beauty of interfaces, and let's just kind of see how this works. What we're going to do is I'm going to be passing this presenter, when it gets created, an instance of display fragment. except it's not actually going to know explicitly that it's a display fragment. It's just going to know that whatever this object is, it implements this interface, it can communicate on this channel. And the way that we do this, the way that we make this sort of legal, is we go to display fragment, and we say implements, what was the thing, calculator contract dot publish to view. And then we again alt enter, implement methods, show result, show toast message. So now what we've done is we've made it so that our display fragment is perfectly legal to be considered this object here, this thing here. This is, in reality, I'll just kind of type this out. In reality, this is going to be an object of display fragment, but our calculator presenter doesn't give a shit about that. It doesn't need to know that this is of type display fragment. It could be really any type as long as that interface is implemented. Now, hopefully you kind of see what the power, what the sort of broader implications of being able to do this kind of thing is. It's really important, and I'll kind of just have to move on at this point because I'm sure this video is getting long enough. But we've got that set up now. Our display fragment says, okay, I'm prepared to handle whatever response is sent through this channel, and our calculator presenter knows that now. So, yeah, I don't think there's too much else. Let's see what we can do here. We can't really do too much else until we create our model, so I think we'll call this done here for now. But that's sort of the gist of our calculator presenter. Go ahead and get that stuff written up. I think actually there will be one more thing we'll do. I wasn't originally going to do this, but we might as well just take care of it now. So go ahead and go to input fragment. And what we'll do, let me just find my place here. Input fragment. So what we're going to do is we're going to set up a communication channel between our two fragments to the presenter. So what we'll do is we're going to type private calculator contract dot forward input interaction to presenter. We're just going to call that forward interaction. And what we'll do is we're just going to say, we're going to create a method called public void set presenter, and calculator contract dot forward blah 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 input forward interaction, and just going to tidy that up a little bit. And let's see here, we're going to say this dot forward interaction equals forward interaction. So again, this is exactly the same thing that's going on as before. This isn't actually, this isn't some magical interface object. This is just calculator presenter, and because it implements this particular interface, this is perfectly legal to do. So again, these objects don't know anything about each other, they just know that they're able to communicate. And we specify those communications. And then what we'll do now is we'll just say, for example, so for on number click, we'll say forward interaction dot on number click. And then we pass button v, so that's going to be v dot get text dot to string. Actually, no, that's an integer. Let's see, how did I handle that? I see what I did. So what we're going to do, this is probably, this is the magic of Java here. So we're going to say integer dot parse int and string s. So what this does is we're actually just going to grab the, we're just calling getText.toString, and then we're converting that to an integer, and then we're passing on. So that's all that's going on there. Let's see, is that all correct? Yep. And then for on operator click, we're going to say, let's see here. It's really just the same step, forward interaction dot on operator click. And here we can just say v.getText.toString. And you notice this is why I actually said button, not view, just so that we could call getText right away without having to cast the thing. And for these ones, we just say forward interaction dot v, come on brain, on decimal click, and we're not passing anything through there. Same deal here, forward interaction dot on evaluate click. And what we've managed to do is we've just now hooked up our input fragment so that it's all set there. So, is there anything else we need to do? Okay, let's just make sure that our display fragment handles everything it should. So in display fragment, once again, we need to create our little interface here. So we're going to say private calculator contract dot forward display, and we're going to again just call that forward interaction. I really hope I haven't lost anyone at this point, but if I have, please do let me know in the comment section. I'll try and clarify anything. I just thought I'd take care of this at the moment because it just seemed smart to do that. Forward interaction, and this is again just the same process. All right, we need to create our method here. So that's going to be, again, just public void. Let me just copy and paste it. That'll be quicker. Where's our set presenter? Input fragment. I'll just copy and paste the set presenter method from input fragment. Paste it in there. And this is actually going to be of type forward display interaction. And everything's kind of set up there. And then once again, just for all of our methods, all of our interface methods, we're just going to call forward interaction on delete short click, forward interaction dot on delete long click. So yeah, we've basically got everything wired up in terms of the display and the presenter. We're also going to need to wire the presenter to the model and then have our activity kind of initialize everything. But yeah, that's basically it. I'm sure this video is long enough, so we'll see you later.